तो हेलो एवरीवन, वेलकम टू टुडेस लेक्चर। आज हम लोग करने जा रहे हैं स्ट्रक्चर ऑफ एटम का लेक्चर नंबर 4। और आज का जो हमारा टॉपिक है वो है बोर्स एटॉमिक थ्योरी। ठीक है, पिछले लेक्चर में हम लोगों ने किया था कि रदरफोर्ड एटॉमिक मॉडल, उसके ड्रॉबैक्स, प्लैंक्स क्वांटम थ्योरी, ये सब किया था। आज हम लोग जो करने वाले हैं वो है बोर्स एटॉमिक थ्योरी। ठीक है, तो लेट्स बिगिन डायरेक्टली विद द टॉपिक बोर्स एटॉमिक थ्योरी। बोर्स एटॉमिक, देखिए, जब रदरफोर्ड का मॉडल फेल हो गया, व्हेन रदरफोर्ड्स मॉडल फेल, then came Bohr to modify his theory, right? Not entirely, he gave also few postulates, but he, to some extent, he modified this theory. Okay, so to overcome those drawbacks, what Rutherford's model had, this person Bohr proposed certain postulates. So we need to know that what were those postulates. First and foremost postulate that Bohr said. Bohr said, Bohr said that atom, there is an atom, let us say, first let me tell, then I am writing, okay. An atom will consist of a very small heavy particle, that is a positively charged particle at the center. This too Rutherford also said, that is not a problem. Electrons will be revolving around that nucleus, that also Rutherford has said, that is also not a problem. But Rutherford could not explain stability of the atom, right? This was a defect, right? So what did Bohr say? Bohr said that the electrons revolve around the nucleus, in specially permitted orbits, called energy shell or levels. That is, electrons will be revolving around nucleus, it's fine, but they will be revolving in specially permitted orbits, which will be called as energy shell. What does this mean? This means that if the electron is revolving around the nucleus, they will be doing so in some specially permitted orbits, which will be having fixed amount of energy. Those energy won't change. This explanation was not given by Rutherford. That is why his model did not explain stability. Okay. So this is, let us take one orbit. Inside this there will be another orbit. Like this. There is a second orbit. Then there will be a third orbit. Like this. Okay. At the center there is a nucleus. Let's say this is a nucleus. So the electron is revolving, the electron is here, the electron can be here, the electron can be here. But the energy of these three is not the same. But the energy throughout this is same, throughout this is same, throughout this is same. It's not like energy is here different, that is not possible. Okay, so energy is same for one orbit. Clear? So what did we name these orbits as? We designated these orbits as something. So these orbits were designated as K, L, M, then N, then dot dot dot. We needed till K, L, M, N only because after that is not discovered yet. So this was the naming pattern. Clear? Now many of the books you will also find written as 1, 2, 3, 4 dot dot. But usually we write it as K, L, M, N only. So is it understood? The first postulate of Bohr, the electron revolve around the nucleus, especially permitted orbits called energy levels, right? These orbits will have fixed energies only. So let me better write it, otherwise we will forget. These shells are associated with definite. This is a very, very important line, that these shells are associated with definite energy. That means energy won't change. Next postulate. Coming to the second postulate. The energy of an electron let us write in a better bhasha. as long as the electron revolves in a particular orbit, it neither gains energy nor loses energy. It neither gains nor loses energy. Very, very important postulate. It will neither gain energy nor lose energy. This statement is very important in the sense. Previously, we have seen for Rutherford's model, the exception that had come. That is for the drawback actually. The exception that was given by the electromagnetic theory. Right? The electromagnetic theory said that charge restricted particle will continue to lose electrons, so ultimately electrons should collapse with the nucleus. That should have happened, but that does not happen. Why does not happen? Rutherford could not give a explanation to Maxwell's theory. But now Bohr has said it, that as long as electron is revolving in a particular orbit, the electron will neither gain energy nor lose energy. So that electromagnetic theory will not be applied. Understood? So this is the postulate number 2. Clear? Now you see, in the first line I have said specially permitted orbits. Right? This postulate, this word will be better understood in this third postulate. What do I mean by specially permitted orbits? So write down the third postulate. Only those orbits are permitted. Only those orbits are permitted in which the angular momentum of the electron, hopefully you all know what is the angular momentum. The angular momentum of an electron is a whole number multiple of h by 2 pi. This is the most important postulate of Bohr's atomic theory. Most important postulate. Very, very important. Did you understand what does it say? It says only those orbits will be permitted whose angular momentum will be a whole number multiple of h by 2 pi. This entire thing is a very important thing. Clear or not clear? So there has to be a whole number multiple of h by 2 pi. Then only those orbits will be permitted. Otherwise they will not be. So what is the formula for angular momentum? That is you have done in physics. That is mvr, right? There are many other formula, I omega and all that is not needed here. We are not doing it in the inertia. So mvr we will write. Then mvr. What is shown? Whole number multiple. So let that whole number be n. Let that whole number be n. So n must be multiplied with h to get this. So this is the equation. So this is the equation. MVR equal to NH by 2 pi. Now this can be h by 2 pi, this can be 2h by 2 pi, that is ultimately h by pi, that can be 3h by 2 pi, that can be 2h by pi. Many things can be, but it has to be a whole number multiple. Anything other than the whole number multiple won't be permitted as a orbit. Clear? Bohr's third postulate clear to everybody? Any doubt regarding Bohr's third postulate? No. Clear? Right? Next. Next point is, and the last and the fourth postulate, that is, energy is absorbed or lost only when electrons jump from one energy level to another energy level. One energy level to another energy level. Did you understand what does it mean? Did not understand. I am explaining. Dekho, explanation is important, but concept should be clear. Okay. See. What am I writing? Let us take a circle. Speak up a circle. Suppose this is for an orbit. Okay. Inside there is another orbit. I am not drawing the nucleus. Hopefully you will understand there is a nucleus in the center. Okay. Achha. So, suppose let us take nucleus, electron was here, now the electron is here. Okay, same electron has jumped from here to here. Now you think, you understand by giving a basic example. See, suppose you are trying to walk up a staircase. Okay, you are trying to walk up a staircase. This does not look like a staircase. You are trying to walk up a staircase. Okay, in a staircase. You are standing over here. You want to get over here. So what will you do? You have to do some work. Then only you can go up. You have to do some work. Then only you are going up. So for that you need energy. So to go up you need energy. To go up you need energy, right? You need energy to go up. So what will happen? This electron, if it wants to go to the higher shell, it will need to absorb energy. But will it absorb any sort of energy? No, it will not absorb any sort of energy. It will only absorb that much energy that it will be needed. That is the energy difference between them. Okay, it will not absorb any amount of energy. It will absorb only the delta E amount. It will absorb will be the E2 minus E1 value only. This is also a very, very important concept. You are giving electron an enormous amount of energy. Everything it will absorb? No, it will absorb only the amount needed for it. If you are giving it too much energy, your plate is already full and you are trying to eat much, that is not possible for you, right? The electron you cannot give so much energy. So whatever is, this is the energy 1, this is energy 1 and this is energy 2. So the difference between the energy that will be needed for the electron to go, and that will also be the energy that will be released if it comes from this position to the lower orbit. That is, if the electron now comes from here to here, then the energy release will also be this delta E, and the energy required from for the electron to go from E1 to E2 will also be the same. Clear or not clear? Understood? So initially we have seen the electron is at position E1, that is position, that orbital, that also not orbital, that orbit, which energy is E1. So that we will call it as ground state. What we will call it as? Ground state. Ground state means the original state. Now if the electron jumps from there to another higher orbit, that is called the excited state, because the energy will increase, the higher energy state. Clear? Understood? Understood or not understood? When the electron is in normal state, let me write here, when the electron jumps to a higher energy orbit, then it is called the excited state. What it is called? That excited state. When I will be talking about electronic configuration, there you can better understand what does the excited state mean. Right now I cannot tell you about that. We will not able to understand. Okay. Clear? When electron comes to the higher energy orbit, excited state. When it is in the normal state, it is called ground state. Clear? When electron is in its original orbit, electron is in its original orbit, it is said to be ground state. Clear? It is in the original state, so ground state. But if it is in jumping to some higher energy orbit, it is an excited state. Clear? Now you tell me. The electron requiring an energy amount, the energy that electron requires, is it up? No. Gradually the energy is changing? No. The energy is not changing gradually. Why? Because if you gradually give energy, the electrons one by one will not shift. But suddenly electron will shift. So the energy is abruptly changing, not at continuous. Like you are giving energy, electron going at once, that is not happening. Suddenly the electron will go. There is an abrupt change. So that is why whatever spectra you get, that is called discontinuous spectra. Whatever spectra you get, that is called discontinuous spectra. I think I have told about spectra in the last lecture as well. Absorption and emission spectra I have told already. So you know what's a spectra, I think. Okay. So this will be a discontinuous spectra. What type of spectra? Discontinuous spectra. Discontinuous spectra. Discontinuous spectra. Clear? Understood? This is all about Bohr's atomic model. The postulates of Bohr. It is not N. It is the Bohr's postulate. Clear or not clear? Any doubt? No. Now, merits of Bohr's model and all that. Hopefully you can manage that, right? I did not say write down now the merits of Bohr's model, because that's not a question to be asked class level. But let me just talk about it. Bohr's successes, if you go for, you will find that Bohr's model had explained the stability of an atom. Stability of an atom, this is the case we have already told. Two postulates are explaining this. That is, when electron is revolving around an orbit, it will not lose energy nor gain energy. So it is stable. Clear. Next, second postulate, second merit. Bohr's concept explained the atomic spectrum of hydrogen. Hydrogen atomic spectrum is a very important spectrum which I will be talking about next only, and I will explain it. Okay? Just for now know that this ground state has minimum energy. That much you have, I think, understood also. The ground state will have minimum energy. Here though it is absorbing energy, so of course more energy than the ground state. So ground state will be the minimum possible energy. That means electron will be as close as to nucleus. Clear? Clear or not clear? Understood? Any doubt till this much? No doubt? Okay, fine. Chalo. In your book, you will get a simple derivation of all this. Delta E equal to E2 minus E1, you all know. Delta E means also H nu. Nu will be equal to E2 minus E1 by H. That is nu. Now nu is also C by lambda. From there you are getting one equation. That equation you all already know, so I did not talk about that equation. I hope so I did not talk about that equation, because you all already know. Do I need to talk? I am talking about this equation. Very simple equation. Delta E equal to E2 minus E1. Just now I got this. What I am writing, delta E is H nu. This I have already told you before also. This is E2 minus E1. No problem. This nu I am transferring it into this way. E2 minus E1 by H. Now nu is also equal to, C by lambda, if you remember. Right? Nu H equal to C by lambda. Frequency equal to C by lambda, right? So what can I write instead of this? C by lambda equal to, it's not alpha, lambda. C by lambda equal to E minus 2 minus E1 by H, right? So can I write AC equal to AC by E2 minus E1 equal to lambda. Clear? That is one of the formulas. This is one of the formulas. So wherever you will get to use it, you will use it, because you already know this formula is actually, you already know that E equal to AC by lambda. So what all we have done is this has come here, this has gone, nothing more than that. Equal to AC by lambda you already know. So from there only we have written it directly, but written a different way, like twisted way, nothing else. Clear? Okay, now the biggest question for the day. We are going to study the hydrogen spectrum. But before that, I have a question. What is the question I have? I have a question. This is hydrogen spectrum. Okay? Hydrogen spectrum. We are going to discuss now about hydrogen spectrum. Okay. Before that, I have a question. What is the question? Hydrogen has only one electron. You everyone knows that hydrogen has only one electron. Art. If hydrogen has one electron, then why it is giving so many spectral lines? What is the reason of that? It's a very famous question. If hydrogen has only one electron, then why it is giving us so many spectral lines? So let me write the question. It's a very interesting question, right? Question is very interesting. Question is, why does hydrogen give so many spectral lines despite having one electron? So many spectral lines despite having only one electron. Famous question. So the answer must also be a famous one, right? The answer must also be a famous one. So it's your homework to research and get hold of the answer and tell me in the next lecture. And I mean in the comments you will tell me. I will be taking your answer in the next lecture. and I'll be telling you the answers. Clear? So this is your homework. What is the homework? Why does H2 give so many spectral lines despite having only one electron? Only and only one electron. Clear? So this will be your homework, which you will be telling me the next lecture. Let us move on. We will be studying about the different regions. What we will be studying about? We will be studying about different regions of spectrum. Okay. Starting with, we have to study about 5 regions. 5 regions. Okay. Not in details. We will be just knowing about the names and the corresponding N1, N2 values. And calculation, simple Rydberg equation I have already taught you before. That formula, if you remember, the Rydberg equation, R value into 1 minus N1 square minus 1 by N2 square Z square, that formula will be applying there. Here I will be giving you the N1, N2 values, nothing more than that, okay? So, we have 5 series. First one is called Lyman series. What is the series? First one is called Lyman series. Lyman series. For Lyman series, very important, please note it down, okay? For Lyman series, first let me give you the names of all those, then I am saying you the numbers. Number 2, we will be learning about Balmer series. What series? Balmer series. First one is Lyman series. Second one is Balmer. Third one is Paschen series. What series? Paschen series. Third one is Paschen series. Fourth one is called Fund series. What series? Fund series. Is it really Fund series? No, not Fund. Fourth one is not Fund. Fourth one is called Bracket T series. Fourth one is called Bracket T series. The way to remember the spelling is that last one is Fund series. Last one is Fund series. Clear? Understood? Now let us mention about the N1, N2 values for all this. N1, 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 N2, 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 N. For Lyman series, very important, for Lyman series, the N1 value will be 1. What will be the value? 1. For this 2, 3, 4, 5. Tell me, clear or clear? Very easy. 1, 2, 3, 4, 5. If you remember this order, then this order won't be a difficulty for you. Clear or not clear? One, two, three, four, 5. You need to just remember which thing? Lyman, Balmer, Paschen, Bracket T, Fund. If you don't remember that, then it's a problem. Otherwise, not a problem. Right? Now coming to N2. Arch. 1 is told. So definitely the electron cannot come from 1 to 1 only. That is not possible. So where can the electron come from? From 2, 3, 4, 5 to 1. So N2 values can range from 2, 3, 4, comma, dot. Usually it's till 7, because till 7 we have discovered. After 7 it might exist, we have not discovered it. But till 7 it is discovered. So from maximum from 7 to 1 it can come, okay, as of now. But it's not an ending now. Okay, so I have made dot. So 1 to 1 is not possible. So of course it will come from 2 minimum. Now coming to N1 equals to 2 for Balmer series. For Balmer series, if N1 equal to 2, it cannot come from 1 to 2. That is not a dropping. Right? That is not dropping. That is again jumping. That jumping to be cannot consider. It is dropping. Clear? So it is from minimum from 3, then 4, then dot. For 3 it will be from 4, 5, then dot. For 4 it will be 5, 6, 7, then dot. Clear? For this it will be 6, 7, 8, dot. After this also one is there. That is called Humphrey series, but that is not there in the syllabus. So I am not worrying about that. Humphrey series is there. Okay, this is clear. There are 5 things we need to remember. Now coming to the important thing, range. Range means what? Not the domain function range. Not that. Okay. By range I mean to say which region of this electromagnetic spectrum will be falling. Clear? So very important thing. Please note down. Very important. Please note down. Balmer series. only series to lie in visible region. That means this is the only series which we can see. Clear? So Balmer series lies only in the visible region. Lyman series is the only series. Lyman series is the only series which lies in the UV region. Which lies in the UV region. Rest 3 series. Which region? IR region. Hopefully you know the meaning of IR. It's not iridium, it's infrared. Clear? So they lie in the infrared region. Now tell me, any doubt till now? So which series can we see? We can only see Balmer series. First chain bracket people, they are lying in the IR region. Lyman lies in the UV region. Clear or not clear? Now tell me, any doubt till this much? Any doubt? No doubts? Very good. Now a little bit of so-called Gyan. Okay, so-called Gyan. So let's have a little bit of Gyan. This Gyan will help you in JEE and Neet as well. Let us have a little bit of Gyan. What is that Gyan? This Gyan will help you in JEE. The Gyan is, if you have to calculate the number of spectral lines, what you have to do? You have to calculate the number of spectral lines. This question has been repeatedly asked in JEE and Neet as well. Okay. Number of spectral lines, electron jumping from which shell? N2 to N1 shell. N2 level to N1 level, electron is jumping. What we have, how many number of spectral lines will be formed? Okay. Electrons are jumping. So in that case, the formula we will be using is N2 minus N1 in bracket N2 minus N1 plus 1 by 2. What nonsense was that? So it is actually N2 minus N1 bracket N2 minus N1 plus 1 by 2. This is the formula, simple formula. Okay. Let me give an example so that you all don't later on complain. So example, suppose electron falls from, not free falling, okay, falls from N2 equal to 5 to N1 equal to 3. Fine. Calculate number of spectral lengths. Calculate number of spectral lengths. Then answer N2 minus N1, N2 minus N1 plus 1 by 2. So what is N2? 5. What is N1? What is N2 N1? Plus 1. Divide by 2 into 2 plus 1, 3 by 2. So ultimately there will be 3 lines. Tell me, clear or not clear? So ultimately there will be how many lines formed? 3 lines that will be formed. Clear? Clear? Any doubt? No doubt? So this is the way I'm going to solve the questions. Done? This was the series and all that. This was the series and all that. Okay? Achha. I have already discussed about Rydberg constant and Rydberg equation. So I do not think I need to again talk about Rydberg equation. That you please watch the previous lecture. The formula of Rydberg equation and all that I have already told you. And the region that I have given you, this formula, this N1 and N2 values, we will just simply put in those formula and we will be solving. Okay? So there is a topic called explanation of hydrogen spectrum in your book. That I will not be separately dealing with. I have already dealt with the main part here. The formula is given in your book. You will be simply using this formula. Clear? Okay, few more Gyan I will give. This lecture is going to be very short one because nothing much is there. Okay, so few more Gyan and important formula as well. It's very important formulas from JEE point of view, Neet point of view, IC point of view. So this is very important formulas. Okay. From JEE point of view, Neet point of view, whatever point of view. Number one, energy of nth orbit. Number one is what? Energy of nth orbit. Energy of nth orbit. What is the formula of nth orbit? Minus, comes in minus y due to the energy difference. Due to the energy. Energy at infinity is taken as negative. So as and when the electron comes closer to the nucleus, the energy of the system will decrease. It is simply minus. Okay. So what is the formula? The formula of energy is 2 pi r square. 2 pi r square. 2 pi r square me to the power 4 y n square h square z square. Tell me, clear or not clear? This is the actual formula. I have written it very much correctly. Are you sure I have written it correctly? Because I intentionally write lot of things wrong for you all to figure out. But I will not do that, otherwise you will be confused. So the formula is not 2 pi r square, because where did r arrive from in an atomic ready? It is not possible. So the formula is 2 pi square me 4 by n square h square. Clear? By n square h square. Okay? And z square is upper limit. Z square by n square. Z square is 1 for hydrogen, so we did not write it. Actually the formula is 2 pi r me 2 pi square me 4 z square by n square h square. Then number 2. Number 2. This is the first one. Acha, unit. You want the unit as well. Okay. Another shorthand formula is there. That shorthand formula is also there. That is minus 1312 z square by n square kilojoule per mole. This is one formula. Minus 1312 z square by n square. Another one is in electron volt. Electron volt. That's before that, let me tell about the joule one. That is minus 2.18 into 10 to the power minus 8. Z square by n square only. Z square by n square. This is in joule, right? And another one is there. That is in EB. That is minus 13.6. 13.6 z square by n square. These are the three short forms that you will be using, because it's not always possible to substitute that big values over there. So this is the short that you are going to use. Minus 1312 z square by n square, minus 2.18 into the minus 18 z square by n square, and minus 13.6 into z square by n square. Clear or clear? Done. This was all that we need to remember from here. Okay. Next I am coming to Bohr radius. That is radius of nth orbit. Radius of nth orbit. Radius of nth orbit. What is the formula of radius of nth orbit? The radius of nth orbit, n square h square was below, now it is up. N square h square divided by 4 pi square m e square z. Clear? This is the formula. N square h square by 4 pi square m e square z. No short form, z is a short form, because you cannot remember so much things. So obviously there has to be a short form for you. So the short form is 52.9 n square by z picometer, or 0.529 n square by z angstrom. Clear? 0.529 n square by z square angstrom, or 52.9 picometer. This is the radius of nth orbit. Radius of nth orbit. Then direct, as you can see, direct questions are there. They will be directly asking you the value. You have to write for that. Clear? Any doubt? Any doubt up to this? Check it out. No doubt? Okay, fine. Next one is the last one. Last formula. No, sorry, second last formula. Number 2, right? No, number 2. Second last formula, that is number 3. Velocity. Velocity of electron in nth orbit. Velocity of electron in nth orbit. What is that? Velocity of electron in nth orbit? nh by 2 pi mr. nh by 2 pi mr. Clear? 2 pi nh mr. This r is what? This r is actually this r. This is r. R value we have got. Substitute the r value over here. After substituting the r value, we will see something that cancels up. Okay. So I am writing put r equal to nh, put r equal to n square h square by 4 pi square m square z. Okay, put this. So you will get ultimately 2 pi square z by h. Ultimately we will get this. After cancellation and all that, we will find that we are ultimately getting this value. Clear? No doubt. So this is the ultimate formula for velocity. Okay. Now what is the shortcut? Shortcut has to be there. Now what is the shortcut? Shortcut is this. What am I writing minus this? 2.19 into 10 to the power 6 z by n meter per second. shortcut. Because every time long cut you cannot apply, so you have to apply shortcut sometimes. So shortcut is this. Shortcut is 2.19 to 10 to the power 6 z by a. Here also there are shortcuts. You can see all this directly. You will be using this because you every time you have to solve that big value, that is not possible. But you cannot forget this. Okay, maybe sometime directly the question might be asked, what is the formula or what is the expression for radius of inlet orbit? At that time you forget the main equation and there will be a problem. Okay, then last gear is number of revolution. What is the last gear? Number of revolution. Number of revolutions. What is the formula? Formula is very simple. Velocity by circumference. Now if this is of nth orbit, wait, not wait, very bad English. In nth orbit, then velocity in that nth orbit by circumference orbit. Clear? Okay, so that is equal to what? This value, suppose it is V. So this is V by 2 pi r. Now V value have just now got, substitute the value of V and you will ultimately get number of revolution as 2 pi mv square by n square, which is the ultimate value, and there is no short value for this. Clear? So this is the thing that you need to read from this chapter. That's all. Not from only from this chapter. Wait, I said I made a mistake. Not from this chapter I meant from this part. Bohr's model, this is the thing that you have to read. Okay? This is the thing you need to read from Bohr's model related problems. Numericals are given in the book. So you please practice numericals. I am not right now doing numericals, but I'll be taking up some research sessions for numericals later on. So please practice the numericals because you know numericals will come. So that's all from this lecture. We'll meet again in the next lecture. Thank you for watching this lecture and thank you for supporting our channel because we have reached already 5,000 views. Okay, so keep supporting our channel. We'll meet in the next video. Thank you.